Thanks for coming and hi everyone. You may know me as one of the organizers, as you said, but this time I will present as well about two of my favorite topics, WebViews and JavaScript. No, I actually hate them both. I do have to write sometimes some JavaScript. I hate every minute of it. But anyway, you may remember, and actually I wanted to ask whether one of you were here or remembers the topic or the talk, the first version, first part of this talk from last year. So show your hands if you attended it. Okay, we have a couple of people, that's fine. That was overcoming insecurities in WebViews, and this one will focus on JavaScript side, so if you want to run JavaScript on it. Basically, I presented it right here in this office, so I work as a senior software engineer at Nevis Security, which is basically a product company focusing on customer identity and access management products from the server side to the mobile side, but I'm a mobile developer. I work on SDK and white label applications as well. React Native, Android, iOS, React Native, and Flutter too. Let's get to the topic. So previously on overcoming insecurities. Oh, that felt great. So last time I talked about more general misconfigurations with a WebView that you may do if you actually show some web content in it. So the first one was leaving the remote debugging enabled, which means that you let other people potentially access your WebView, debug your WebView via the Chrome inspect tools. I also talked about not allow the clear text traffic, which is basically, even if you turn it off in the network security config, it still doesn't respect it, or it's not respected until Android 8. It was a good gotcha. I also talked about HTTP strict transport security, which is only relevant if you do want to allow clear text traffic. I also talked about setting the base URL to not fail the cross-origin checks. So basically, there's a method to properly set it. I also talked about how file access and content provider access is turned on until some of the Android versions, I think 11. And it will come into play in this talk as well, at least the file one. I also talked about how not properly clearing the cookies can be a problem, especially considering that the cookie jar is shared between all of the WebViews running in the same process. And I showed you a breakout demo, which is basically not really a high-risk problem, but it's an interesting one of navigating away to a page that you are not supposed to be able to access. Now, I also talked a little bit about JavaScript, but due to time constraint, I couldn't get into it. I basically just said that, or highlighted, and I want to underline it again, that the JavaScript rendering runs in the same process as your own application up until Android 8, meaning that potentially it can access the memory space of your application. I also showed how you should use evaluate JavaScript instead of the load URL, because I don't know if you know, but load URL, which is supposed to load URLs, handles JavaScript as well as kind of a side effect, but you shouldn't do that. You should use the evaluate JavaScript. How you need to sanitize the inputs, especially if you put it into the JavaScript, and especially if it's coming from a third party or a user. And restrict the JavaScript bridge. And I left this as this, and I will now elaborate on it soon. Not accidentally, I received most of the questions about running JavaScript in the WebView, so that's why I decided to make this second part of the talk. But if you are interested in the first part, check it out. It's now on YouTube. The best delivery was it from DrightCon London. That you can check it out if you want from this QR code. Anyways, it all starts with this humble line. Basically, many suggestions on Stack Overflow and so on, and probably, let's be honest, nowadays probably Gemini or some other LLM, says that you should not enable JavaScript to avoid the security problems with it. But today, we are talking about the case when you want to evaluate JavaScript, want to run JavaScript. That's the thing that you would like to achieve. So that suggestion doesn't help you. So you put this, and I will assume that this is in the code from now on. Or probably it looks like this, because now Android Studio even warns you that you should not do this. But let's say that we are adamant, we want to do this. Now, how you can do this? Up to this point, up to very recently, the best way was running so-called headless WebView. It's not called like that officially, but this is how it's often referred to. This is a WebView that's not part of the UI, but it's initiated from the code side. So something like this. You initiate it from the code side, you need to pass an activity reference to it. So that context needs to be an activity context to run it correctly. And as I said, you use the evaluate JavaScript code. Technically, you can use the load URL again, but don't do that. So you should use the evaluate JavaScript, which gives you a callback where you can handle the result at the end. But again, this is a callback-based API. Keep in mind, it's not really easy to integrate it with something like coroutines. Let's see the problems. I will go through some of the interesting problems, but I have to warn you already that the line of the list of problems are endless, I have to say. But the first one I would like to highlight is missing the scheme validation, because you might assume that URLs are pointing to web content. But URLs are not really URLs, just URIs. So these not necessarily have the HTTPS scheme. They can even have the JavaScript scheme. It can even be passed, as I said, to the load URL. But not just that. So you may receive something like this, which you think that you restricted the content to your legitimate domain because you checked the domain itself. But this will complete that check, although it has the JavaScript appended to the end if you check it. So you expected this, but you get the JavaScript instead, which will both work with the domain check. So let me actually show you, because this time I wrote demos as well, like last time. Let's see the simple case first. Why it doesn't want to? It works on the device, not in the share. Awesome. OK, now it works. So let's say we have the access to the field, but it can be from JavaScript as well, and to run this nice URL. If loaded, it throws up a nice pop-up. But it can be from code as well. This variant simulates it running from the code. Of course, it doesn't need to be user interaction involved. It can just run the JavaScript inside and show things. And of course, showing a dialog is not the worst thing it can do, but this is how I choose to demonstrate it. Now, what you can do is to validate not just the domain or the authority. In this case, I might actually show you this as well. So this check is basically what's implemented here, but this only checks the authority, which is basically the domain. But you shouldn't just check for the domain. You should check for the scheme as well. And only allow the schemes that you want to support. I always want to highlight this, that in security, it's always better to use an allow list, not a block list. So you shouldn't just look for the things that you want to block. You should instead check what's coming in is the part of the things that you would like to allow. So you need an allow list, preferably on the HTTPS. Especially from the load URL calls, because that's not what you want to have JavaScript coming in. OK, I said that accessing files is enabled by default up to a certain Android version, I think 11, but I included it later. And how it can be accessed. Last year I showed you if the user or some input coming from outside have access to the load URL call, then they can just pass a file URI to it. But with this beautiful thing called XML HTTP request, or XHR, even JavaScript is able to call into files and access files. Basically, the exploitation is possible if someone else is able to control the path of the file that is returned, because you may want to have this. You may want to serve files to the JavaScript. But if the path is not controlled by you, or you are not enforcing what kind of path can be called, then an attacker can just call arbitrary files, open arbitrary links with the scheme. So an example attack can look like this. This creates an XML HTTP request at the top. This is JavaScript. And then calls the open call with the file URI appended to it. Basically, mitigation is pretty easy. You just don't need to enable the file access if you don't want to allow this. But keep in mind that you need to disable both the allow file access and the allow universal access from file URLs, depending on the Android version that you are running. So you need to set these to false, or otherwise you need to intercept the requests coming in and check what files are served. There's a special version of this when you basically want to emulate a server inside your application. So intercept the calls that are executed in the WebView and construct the response. And you can do this with the WebResourceResponse, which is a pretty old API, I would say. And this is basically how it would look like for even a relatively simple call. Now, I put this in mostly to scare you. Now that you are scared, let's go a little bit into it, but let's not be lost. But how you do this is we have this WebView client, and then it has this should intercept request callback method that you can implement or override to basically get the requests once they are fired. And then you can respond to them or let the system respond to them if in certain cases, but you can put logic in there. And then in this simple case, for example, and this is based on a real-time or a real-world case study I will show you in a minute or where you can read up on it. So let's say in this case you want to serve files from the cache, and how you publish it to the scripts running in the WebView, you expect the file URI at the end, appended to the end of the normal URL. So you get the last pass segment from it, and then create the file from the cache directory. And this is the part about the WebResourceResponse, where you construct basically how a server would respond to a call. You basically set the 200 OK HTTP responses, and also you need to be aware of the cross-origin or same-origin checks. So you need to be aware of all of this just to respond to this. So all is to say, let's not do this. I will show a better way in a moment. But an example, a proof of concept exploit for this would be something like this, where you would like to fool the code to accept your check even if it's not coming from the real website. You replace basically the real domain with something else, and you encode the value. So if the attacker has control over that encoded path, or the JavaScript that you load can come from outside. And remember, even if you allow it, for example, your website that you show, it may have iframes, some other code from outside running in it, which has the same, basically the same rights as the embedded website. And this, as I said, it happened before. Not even an unknown application. If you read the URL, you can find out which application it was. It's a web-based application, and it was exploited in this exact way. What you can do basically is to use the WebView asset loader API together with the WebResourceResponse. If you really have to do this, if you really want to answer the calls, the WebView asset loader allows you to parameterize what files, or what assets rather, what assets you are making available to the WebView callers based on what URLs. So you don't need to use the you don't need to use the file URI. You can parameterize what URLs points to what files. And this will be compatible with the same origin checks without the magic or the boilerplate you have to do in the pure methods. You can read up on this if you want. It has some nice documentation from Google how you can do this. So every time you need to do WebResourceResponse, you should use the web asset loader as well. Just really briefly, this is how it would look like. You use the nice builder pattern of it saying what URL points to where. And then in the same should intercept request call, which, by the way, there are two, obviously, because for legacy reasons, there are ones that only usable below a certain API. But it doesn't matter for us, really. Just what I want to highlight is that you can directly forward the calls to the web asset loader rather than constructing the response yourself, and the system handles this correctly. OK, we need to talk about cross-site scripting. We already did to some extent, and I like to say that we as Android developers, when we need to work with WebViews and web content in general, we are basically reliving the same things as web developers did 10 or 15 years ago. Cross-site scripting is pretty often or pretty common, and the mitigations are pretty common as well, but as Android developers, we are maybe not that familiar with it. It is basically code that runs on the client side that's injected into a web page that you load. Obviously, you can imagine the problems with it, which can vary in range quite widely. It can be pretty nuisances, like showing a dialogue, which is probably not a big problem. But if you can imagine that if sensitive data can be accessed, then the script that runs on the client side may do nefarious things. So on Android, this is exploited on WebViews via the JavaScript Bridge, which makes possible to call native methods from inside the JavaScript, or from inside the WebView, sorry. How you do this is you call the add JavaScript interface method that basically injects the supplied object that you pass as a parameter into the WebView. Interesting to know, I already alluded to this, that this makes it available not just to the embedded page that you probably intended it, but also any kind of subpages that are included in, for example, iframes. Now, the JavaScript objects that you pass, its methods needs to be annotated with the add JavaScript interface annotation. Only those are accessible, sorry. Only those are accessible, and the fields and properties are not. How it looks like, basically there are 3 parts of it. The custom class that you have, it is annotated with the add JavaScript interface, the methods. It has to have at least one of its methods annotated with the add JavaScript interface. You have the WebView setup, probably in an activity or fragment, where you call the add JavaScript interface, and finally you have the script that loads it. Now, we'll go through it a little bit. As you can see, here's the add JavaScript interface annotation on this getToken method. You might already assume what will be the problem here, but this means that this method will be callable from the WebView, from JavaScript. And then you call the add JavaScript interface, passing an instance of this class you created, naming it. The last parameter is the name. That's how it will be accessible from the script. And finally, if you check the script side, it actually calls a method from the JavaScript. This will be a native call on your Android side. OK. I have a demo for this as well. So visually, it looks very familiar. We press a button, but again, it doesn't need to have user interaction. The JavaScript code can just run itself. And what it does is accesses some secret. Now, this is the token in this example. So if you check, the problem here is that we have the getToken method annotated with the add JavaScript interface, and now this is callable. You may intended this to be callable by the embedding page, but maybe there are some other page or advertisement, for example, that's inserted to it, and that can call it as well. But I have to say JavaScript Bridge used to be way, way worse. So up until Android 4.2, it's quite a long while ago, I know, happily, non-annotated methods were also accessible via the JavaScript Bridge using reflection. So they can the exploiter or the malicious side can just call into, and this I couldn't demo because I don't have such an old device anymore, luckily. But I got this example from the internet, and if you check it, it basically uses the runtime class to actually use some Unix commands. So it was pretty nasty. Hopefully none of you need to deal with such old devices anymore. If so, then I don't know, quit. How you mitigate is basically seems obvious, but doing it might not be obvious. But you should restrict the JavaScript Bridge, and that's what I meant in my last talk. Now you see that you need to think about what kind of method you annotate, because from now on those are accessible from outside. And also you should assume the malicious intent from the caller side, especially if you run the JavaScript that's not packaged within your application, so it's not in your control. Or of course you can only run JavaScript package within your application, which gets rid of many of the issues here, except if this is possible to change that JavaScript, but that really goes into very deeply like app repackaging or something like that. But anyway, if you are sure that the content is trusted, then these problems are not coming up and not exploitable. But if you run JavaScript from outside, you need to very hardly think about what you allow. Android components are accessible as well, and I don't just mean the content provider that I showed you last year with the URL. Basically, there's a way to exploit or take advantage of the JavaScript Bridge to launch an Android component, because remember that the native part of the call will be in your application's with your application's rights. So anything that the application can do, this call will be able to do. I don't know how many of you know that if you use an intent scheme, again, another scheme, not just HTTPS, or it's not the only scheme, there's an intent scheme as well, which Android handles. And part of it is the component and selector fields, which can point to an Android component like an activity. So how it can look like is that you want to allow launching some components. Let's say you want to allow opening a URL. I know it's a pretty weird example because you are in a WebView, but let's say you run JavaScript in a headless WebView and you want to actually show some web page. And you have this nice open URL method that you annotate with the @JavaScript interface, which starts an activity based on the URL that you receive. And you might want to use the intent's parse URI method to parse the URI. Now you might expect some JavaScript like this, but you might get something like this instead. And what it does is uses the intent scheme that's mentioned inside of it. And if you check, there's this component field, which points to an activity in your own application. If you want to mitigate this, let's show it first. Sorry. So this example, again, the familiar button, but if you press it, this launches actually an activity, another activity of your application. And if you check if we check the manifest, this secret activity is not exported, so it should not be launchable from outside. But again, this method in the JavaScript Bridge runs in the context of your application, so of course it can launch it. How you can deal with this is that you can add the category browsable or null out the component and selector fields after you parse the URL. This will make sure that it will launch in a browser. Or you can also check whether the component that you intend to launch is exported and only allow it to be launched when it is. Or you can add, of course, other checks as well based on the URL that you receive. But even better, if you don't use the parse URI, I would actually don't use it at all, because there's a constructor of the intent which doesn't have this kind of issue. It doesn't take the component and selector fields into consideration. The URI that you pass here will be in the data, in the bundle, basically, instead of being able to launch another application. So that's what you should really do. OK, a demo. I already showed you the demo. Finally, I would like to say that you should think through the functionality you would like to provide and only allow things that you actually want. Use the constructor of the intent and set the component and selector fields to null. Also check the exported status again for the component and only launch it if it's possible. Of course, if you want to launch an external browser, that will be exported. Finally, JavaScript engine. Because I'm really happy about this, actually, because this running JavaScript locally is kind of, in my opinion at least, one of the last use cases of using a WebView. Because for the other use cases, showing content, you have now the Chrome custom tabs, which I talked about in more details last year, Chrome custom tab, or delegated to an external browser, which are all better ways. But running JavaScript locally, as I said, headless WebView was kind of what we were stuck with. Technically, there was a third-party library, which one of you mentioned last year, which is still alive, by the way. But I don't know. I don't have any experience with that. You can check it out. Unfortunately, I don't remember the name. But finally, Google released JavaScript engine. Last year, I actually said that it's not released because it's only beta. But this summer, so just this summer, they released the 1.0 version of it. And what it does is basically allows you to have multiple isolated environments, so they cannot talk to each other, they cannot talk to your code. JavaScript just runs on it with relatively low overhead, and it's based on the asynchronous listenable future interface, so it's awaitable, it plays nicely with coroutines, and so on. Still uses WebView in the background, by the way, because WebView is an application as well running on your phone, and it still communicates with that, so you need to have that installed on the device, and also a version that supports this. Luckily, the versions are supporting it for a while, and there's an API to check whether this is the case. Also, it can run in a service. It no longer requires an activity reference. But it's only available from Android 8, so if you want to support older applications, or sorry, older Android versions, then this might not be the tool for you. And the last thing, which is both a blessing and a curse, in my opinion, that it cannot make network requests. Now, it can be good because it may protect you from calling out to the network, but at the same time, if you want to actually call into network, you cannot do it with this. And I have a very short demo to demonstrate this as well, with a relatively realistic use case of password strengths. Now, I don't want to go on a tangent how not good this is. Some of you may know that I worked with a password manager or on a password manager before. So let's say you have, let's see my really complicated real password here.
But how to overcome the lack of network requests?
You cannot. So if you need to make network requests, you cannot use JavaScript engine. Unfortunately, that's it. You cannot communicate with your native code. That's the point of it. So yeah, then you need to use something else, like a headless WebView. So that's my real, no, not my real password, obviously, but it's a very complicated password. Let's see how it fares. I said I have the time it takes to calculate the password strengths. And I noticed that there's some performance impact with the JavaScript engine. Now, it may be that I haven't spent enough time with it, and maybe it can be further optimized, but in my experience, it's a little bit slower than the WebView, but it's not a big thing. And it's a pretty complex JavaScript. I think my machine would maybe die as well if I load it. Maybe VS Code handles it properly. So it's a pretty big JavaScript. Yeah, it's low on RAM, but yeah, IntelliJ does crash it anyway. So it's a pretty big JavaScript because it contains dictionaries and so on. And again, let's stop I have to stop myself not to go on a tangent about password strengths, but just so you know that if you include a big dictionary of the things that are common, then the attacker just need to exclude it. So then what you have made with the password strengths. Anyway, so that's why it is very big, and why I use the JavaScript is very real, because with the password strengths, currently there's no maintained native dependency of it. So it used to be Dropbox's implementation, but it's not updated for 10 years, so obviously it's not a good idea to use it. There's the Java version, ZXCVBM4J, and by the way, if you wonder about the name, look at your keyboard in the bottom row from the left to right. Anyway, it's also not updated for a year, so the current only version that is updated is the TypeScript version, where it is, this one. So that's what I used in this example. It's very, believe me. Also, the API is much nicer, I have to say. Like, if you use the native call, it's basically, obviously, that's the simplest, you just call method. But with the WebView, as you can see, it's pretty hard to integrate with coroutines because it's callback-based. But if you check the JavaScript Bridge, the JavaScript engine, you just create a JavaScript sandbox. This needs to be created per instance, so you pair your application instance. It's basically a listenable feature. So you just create it once, and it lives while your application is running or while your activity is running. And then this is the important part. You can create these isolates, multiple one of them. Basically, you create one per run. And then you can call this evaluate JavaScript on it, which is awaitable. And then you can have this nice procedural code, which is in reality asynchronous. And with that, we already arrived to the takeaways. But I want to preface with this. Not just don't use WebView. That's my biggest suggestion. There are more modern technologies available. Again, for the UI variant, custom tabs is great. I talked about in details in my last talk. And JavaScript engine, except if you want to call network, or you have to have network access, it's a great alternative, and it is still maintained. But in generally as well, I have to say that I think it was widely used before. I do remember like cross-platform libraries like PhoneGap, I don't know if it rings a bell for anyone, that were built on WebViews, but nowadays React Native and Flutter doesn't do it. They have either a canvas drawing or using native components. So it's not a surprise, and also not a surprise that Google login is not even allowed with a WebView nowadays. So luckily, there are less and less use cases where you need to use WebView. So if you can, try to get away with it. And if not, be aware that you basically then become a web developer, which might be a good or bad thing depending on who you ask. But anyway, you need to be very aware of the many security problems with the WebView. As I said, JavaScript engine, and it's important as well if you package the scripts with your application and you are not, at this point, you are not worrying about repackaging of your application, which you have other mitigations against, by the way, I have to mention. But if you only load JavaScript from a trusted source, then most of the issues are not a problem. Also, restrict the JavaScript bridge as much as you want. Think about the caller as a malicious caller. So think about how the JavaScript bridge or the methods that you publish through the JavaScript bridge can be abused. And think through the edge cases. I always say my best suggestion for cybersecurity is to do threat modeling. I know that I, again, not have time to go into threat modeling as well, but do look it up. It's basically a way to map out how your application's trust levels are changing. So from, for example, your own code, from the WebView code, and you have these trust boundaries and check all the things, or basically you need to draw this out and you say what are going through the trust boundaries and what kind of issues can arise, what kind of exploits can be there, and how you mitigate them. And remember that HTTPS is not the only URI scheme. There are many, many, many more you need to be aware of. Yeah. With that, thank you very much. I was Balázs Gerlei, and you will see the slides soonish, like in a day or so. I'm not that pro that I have it automated, so I need to do it, but I will, to Speaker Deck. That's the first link, and I would like to shamelessly plug my library as well from last year, the Secure WebView library, which is basically an implementation of a WebView that by default has the problematic parts turned off, so it doesn't have file access, it doesn't evaluate JavaScript with the load URL, just with the evaluate JavaScript call, and so on. It doesn't even allow, sorry?
No network instance, right?
Of course, it has network access. No, it has network access, but it also, by default, doesn't allow you to break out to common search engines, because from the demo last year, basically, you get around the web by reaching a search engine first and then going around. It doesn't allow it. It doesn't allow to run LLMs in it, so chatbot. And I still haven't put it up. No, by default. You can turn it off if you want, but by default, it doesn't allow the common ones, at least that I know of.
What do you mean, no element?
It doesn't be able to navigate there. By URL, it checks that you cannot navigate, because you can ask anything from the LLM, and then you can call in any kind of websites. That's why it's turned on by default, but you can turn it off if you want. Also, you can supply what you allow, what you block, and so on. It's still not available with the Maven Central. I need to do that, but you can use Jetpack.io, which at least you know that it comes from this source. And also, it's CC0, so it basically has no license. So you can do anything with it. You can just take the code and run with it if you are not comfortable with running this code. Thank you again.